Making aluminium is a complex process, invented in the 1880s by American Charles Hall and a Frenchman, Paul Héroult, simultaneously. Over 100 years later, the Hall-Héroult process, also known as the reduction process, is still the only commercially viable process for making aluminium. Bauxite is the natural ore used to make aluminium. It is the most abundant mineral in the Earth's crust. Bauxite is crushed and refined into alumina, which is one of the main raw materials for the smelting process. It takes 4 tons of bauxite to make 2 tons of alumina and 1 ton of molten aluminium. At the site in Kitimat, the focus is on smelting and casting. The smelting process occurs in a pot, or reduction cell. It is a complex chemical process that requires 5 raw materials: alumina, electrolytic bath, pitch, petroleum coke, and electricity. Alumina is injected into the electrolytic bath. Pitch and coke are baked on site to produce large carbon blocks called anodes. The electrical current is conducted down the anode, into the bath, through the pot, to the cathode. The reduction reaction that occurs separates out the molten aluminium, which sinks to the bottom of the pot, from where it is siphoned and sent to casting. In Kitimat, there are 384 pots housed in 4 buildings. One continuous line of electrical current runs through them. Although there are 4 buildings, there is in fact only one actual pot line. The anodes are formed in carbon south, transported to the anode bake furnace, then to the rotting shop, where the aluminium stem is installed to ready them for use in the pots. The process in the modernized facility at Kitimat is highly automated with the latest technology and equipment. The bake furnace receives green anodes from our carbon cell facility and bakes them at temperatures of up to 1200 degrees Celsius for 20 days. Over 600 pre-bake anodes are produced daily. Once baked, the anodes are transported over to the storage facility until they are rotted. The storage facility can hold up to 7,300 anodes. The rotting shop is the next stop for the anode on its way to the pot rooms. Here, an aluminium stem is connected to the anode. The stem is placed into a circular cavity in the anode, and molten steel is poured around its base. The anode rotting shop operates around the clock and can produce just under 400 finished anode assemblies per day. The heart of any aluminium smelter is the pot line, and Kitimat is no exception. Each of the 4 650-meter-long buildings houses 96 pots. Electrical current delivered from the busbar system is conducted down into the molten bath via the rotted anodes. Each pot contains 20 anode assemblies, each lasting about 20 days. When they burn out, they are replaced, and the used carbon anode material is fully recycled on site. Anodes are changed without interrupting the actual reduction process. This continuity is critical for the process and depends on the reliable source of power, 24 hours a day, 365 days a year, from Kamana. The technological advancements in the smelter, with the additions of the gas and fume treatment centers, ensure a 50% reduction in the plant's overall environmental emissions. Each one of our AP40 pots produces approximately 4 tons of aluminium every 32 hours. The molten aluminium is siphoned or tapped into crucibles for transport to casting. In casting, the metal is siphoned and released into a holding furnace. It takes 8 crucibles to fill a furnace. Once filled, the furnace inclines, allowing molten aluminium to flow through a trough and into a mold. Along the way, temperatures are measured at various locations to ensure casting consistency. At the Kitimat operations, 3 forms of cast aluminium will be produced. Small form ingots weighing 23.7 kilograms, sheet ingots weighing up to 35 tons, and sows. Each is made to the specifications of our customers. The use of automation ensures a high level of quality control. Product from Kitimat leaves by ship to customers in Asia and North America. The deep-sea year-round ice-free port, one of only 3 in northern British Columbia located so close to the Pacific Rim, positions BC operations at a distinctive advantage and a reliable supplier of aluminium to this growing market.